All right, so for each of these problems, we're going to answer these 6 bullet points here, and we have to use the definitions to be able to solve them. So the first, it says find and interpret C of 0. So that just means take your cost function, which is given to you, and plug 0 in it. So 2 times 0 plus 26, that gives me 26. Then it says find and interpret C bar of 10. So if we remember, C bar means the average cost. So it's your cost function with x plugged in divided by x, or how many items it's going to be. So we take our cost function, which is this, plug in 10, and then we divide by 10. So 2 times 10 is 20. 20 plus 26 is 46. 46 over 10, that gives us 4.6. Now notice there's a lowercase p and a capital P. Remember, the lowercase p is your price demand function. So P of 5. So we're just plugging in 5 into our price demand function. Now it says find and simplify R of x. R of x is your revenue function. So the equation for revenue is x times your price demand function. So that's going to be x times 30 minus 2x, which is, and if I distribute the x, you get 30x minus 2x squared. Then it says find and simplify capital P of x. So that's your profit function. So your profit function is revenue minus your cost. So I take my revenue function and I subtract it from my cost function. Now notice I put parentheses around my cost function because you're subtracting all of it. Distribute. And then 30x minus 2x, that's going to give me 28x. And then negative 26. That's my profit function. Now solve P of x equals 0. So that means we take this and we set it equal to 0. Now having it set equal to 0, that means we have to solve for x, right? This is the variable that I need to find. So this is a quadratic equation, so we can try and factor it, or we can use the quadratic formula. Either of those are going to be useful. Now, if we wanted to factor it, maybe we can try factoring it, right? Quadratic formula, negative b plus or minus, da 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 da. You can do that right now. But if there's a number like in common that I can divide by because it equals 0, it's a good thing to try and do that. So in this instance, there's a negative 2 in common, so I'm going to divide everything by negative 2. So divide by negative 2, divide by negative 2, divide by negative 2. And so that's what I get here. So now factoring this, a times c, 13, factors of 13, that can add to negative 14. So negative 1 and negative 13. So I'm going to get x minus 1 and x minus 13. Now if you forgot or you don't know how to factor, use the quadratic formula. So you're going to get x equals 1 and 13. So let's go through and interpret this, because a lot of these it says interpret. So on that first one, it says find and interpret C of 0. This is the cost when I've produced nothing, which means it's your startup costs. The C bar of 10, that is your average cost. So if I wanted to produce 10 things, it's going to cost me $4.6 to produce those things. Your price demand function tells you if you want to sell that many, that's the price you need to charge. So because I want to sell 5, I need to charge $20 for it. The profit function, that's just the profit function. This is a model. If I sell X amount, this is how much money I actually make, how much profit I get. Find and interpret the P of X equals 0. This is my break-even points. So we break even here. If I sell 1, my profit is 0. If I sell 13, my profit is 0. So it probably means in some sort of model, anywhere in between those, I'm going to make money, I'm going to make profit. Now this process is the same for all 4 of these. You can use this as the template to be able to go through and do all 4 of those. There are 221 students on a field trip. 5 students ride in a van. The rest of the students fill 6 buses. Enter an equation that can be solved to find the number of students S that are on each bus. Enter your response in the first response box. Okay, so there's different ways to look at it. If I already know that 5 students are in the van, so you have 221. If I take 5 students and I'm going to put them in the van, right, so that gives me 216. And so I know that if those students are going to fit into 6 buses, that's going to give me 36 students, right? So we can do some quick mental math with that, right? So it says enter the number of students that are on each bus. Okay, so equals 36. The hard part is coming up with an equation that represents that, right? So all we need to do is just create essentially what it's saying. I have a total of 221 students, and that equals 6 students, or 6 buses per student. It actually says S, so instead of X, I'll use S. And then plus 5 more go into the van. So in this process, subtract the 5, divide by 6. So an equation that we could say is going to be that. And I know, I'm sorry, my S's and 5s look similar. Andreas says that the system of 2 linear equations must have at least one solution as long as the lines have different y-intercepts. For example, the equation y equals 2x plus 4 and y equals 4x minus 6 have different y-intercepts and have this solution. Select the pair that can be used to disprove Andreas' claim. So the claim is false because the claim is false because the idea is, so it says, Andreas says that a system of 2 linear equations must have at least one solution as long as the lines have different y-intercepts. So she is saying, oh, if this is my solution, aha, see, they have different y-intercepts. So what could be the example, or if we visually think about it, what could be the example in which would prove her wrong? Okay, well, the first part of the claim, one solution. Okay, so it can't be the same line. right? Because if it's the same line, that's not one solution. It also can't be parallel, because then there's no solution. So we have to think, okay, what could be the scenario in which they could have the same y-intercept and still have a solution? Well, what if that's where they intersect? They only have one intersect. They're only intersecting once, so they have one solution, but they have the same y-intercept because the y-intercept is the same solution. So that's what we need to look for in here, is what gives us the same y-intercept, one solution. And if you need to use a graphing utility to help you with that, go for it.